her before lunch. And this is Elena Ferri. She's the head of Data Science Center of Excellence in ADP at the Federal Reserve Bank. So I'm really, really excited about your presentation about advancing data science capabilities. So I'm just going to go ahead and give this to you, Elena.
All right. Good morning, everyone. As she mentioned, I lead the advanced analytics and data science team at the Fed. And let me fulfill, first of all, my compliance obligations by stating that the views that I express are my own and do not necessarily represent those of the Federal Reserve Bank of New York or the Federal Reserve System. Okay. So today, we are going to cover some of the key challenges that we have been facing in advancing data science at the Fed and the associated strategies to address them. And some of you, the previous talk actually touched upon some of these strategies, but we're going to go deeper on the strategies. So let's set the context, though, because we are in central banking, and central banking is a special space. So central banks, as you know, I'm sure, they play a critical role in influencing the country's economic conditions and maintaining financial stabilities. And while the objectives that may change from country to country, they usually include monetary policy, bank regulations and supervision, lender of last resort, and foreign exchange management. Now, I'm saying this not to bore you, but because central banks are by construction risk averse. And traditionally, they really move slowly and incrementally, which is a challenge, right? Because they have to change. And the challenge here is that central banking has to accelerate in adapting to a changing world, which is increasingly more complex and data-driven. And so it has to change to meet its mandate. So what we observe is that in general, and only recently in the last few years, data science has been picking up momentum in central banking in order to leverage data-driven insights, enhance decision-making, monitoring the risks, and ensure the stability of the financial system. So let's zoom into, if it works, yes, the New York Fed. Now, the New York Fed holds a very special position in the Federal Reserve System. Now, it goes on its own. Okay, here we go. The system comprised of 12 reserve banks. Now, why is it so special? Its location in New York, its proximity to the financial institutions that it monitors, its jurisdiction. It covers a significant portion of the US economy. It runs open market operations. It's the only one that runs this operation across the 12 ones. And by doing that, he's really buying and selling US government securities to influence the money supply and the interest rate. So it regulates the monetary policy. And it also pivotal in the US for the international relationships with international finance and central banking. So the question is, how do we apply data science at the New York Fed? I don't know why it's not working that well. Okay. So among the 4 project types that you can see listed here, we are primarily skewed towards the first 2 project types, which is really the knowledge discovery from data to get novel and actionable insights, and the data science infusion in processes to gain operational efficiency. So overall, we are using data science for business decisions, policy advice, and research. And only recently, we are integrating data science into product, and we are creating our own products driven by data science. So for example, we are creating our internal version of ChatGPT. But how do we actually assess where we are at? So people talked about a lot of models, a lot of challenges, different strategies. But at the end of the day, if you're not transformational in the business, it does not matter. So for us, what we did, we took the Gartner's AI maturity model, which is very simple, but yet very useful, to assess where we are. There are 5 levels of maturity: plan, experiment, stabilize, expand, and transform. And there is a big jump between the 3rd level of maturity, which is stabilize, and expand. Because with expand, you're fully industrializing it, and you're trying really to become transformational across the whole bank. So, okay. So if we apply this maturity model at the Fed, to the Fed, we see actually that there are different maturity levels across FRBNY, and they're spread between the first 3: plan, experiment, and stabilize. So certain groups are timidly entering the planning phase. Some are experimenting, some are integrating data science into their workflows. And we are actually on the path to become democratized and transformational, but definitely we are not transformational yet. So there are 3 quick key questions that I want to address from now on. One is, how did we get here? Because it took a long time to actually get here. Somebody before was talking about trust. I was talking about working together, getting aware of what data science can and can't do. How can we kind of close the gaps that we have today? And how can we close the gaps for us to actually move to the right and becoming more transformational? So how did we get here? We actually, not surprisingly, we started with very foundational components, and we maximized their applicability across the enterprise. So we kind of monetized these use cases. When we identified the initial use cases, we carefully selected them based on 3 criteria. Business value, we always start with the business value. Feasibility, is it possible to deliver them? And do they have an enterprise potential? Can we actually leverage them across different groups? We deliver successful POC to actually educate the businesses and to improve the business values of these POCs, which, by the way, we defined the success metrics before starting the POCs to engage, and we defined them together with the business. And then we reused the same architecture, delivering use cases or POC much faster, because by reusing the architecture and replacing only the data or the model, we were able to get more traction across the enterprise. So going back to that, so this is kind of the first question I asked before, so we still have 2. How do we close the gaps to actually stabilize more further this kind of landscape? And what are actually the gaps to move more to the right, to become transformational? Okay, so the colors are a little different, but hopefully it works. So one of the top challenges that we have, because again, the business sometimes doesn't know how to ask the right question. So what really keeps me awake at night is, are we really focusing on the right things? Are there some use cases out there that we are not considering? So what we do, we really periodically scan all the business objectives. The business objectives are kind of well-known, and they get kind of updated on a quarterly basis. So we basically anchor to these business objectives because these also are extremely useful for our prioritization framework. But now it's funny because as we actually make the pipeline bigger, we then have another problem because my team is kind of small, right? We work at the New York Fed, the budget is very tight. So how can we keep up with a growing pipeline of use cases? So we try to be as nimble, as agile as possible. So what our operating model has a specific principle which says that we don't set a duration of a POC longer than 2 or 3 months. So at the end of this, you reassign the data scientists and you keep going and you keep traversing the pipeline. Now, okay, so that takes care of kind of my direct team, but as somebody else this morning mentioned, you cannot be successful unless you're really tightly connected to a full ecosystem for data science to work. What I mean by that is that you have information security, enterprise architecture, we work very closely with them, product owners, data management, subject matter experts, and other stakeholders and needed. And this kind of network of relationship is key for a successful data science practice. And the challenge here is that some of, let's say, components or some of the architectural components may not be ready yet. So we need to basically fly the plane while it's being built, as many say. Another challenge that we have is for data science to really become transformational, you need to have data scientists in each business. We call it citizen data scientists or spoke. What we do, we are taking a really active role in growing the number of spokes. And how do we do that? Because the number of spokes, they're not part of our teams. The spokes are part of the business. So what we do, we are implementing what we call the embedding. So it's basically it's a free loan of a data scientist from the center, from my team, to the businesses. They work together on a business project of their choice. And by working together, there is a dual return. So the business is getting upskilled. So learning so many new capabilities that are not necessarily part of their competency or job description. And my data scientists in my team actually learns much more about the business. So when it comes back to the center, is able to proactively suggest data science capabilities for the business. Now, it sounds okay, right? I was like, okay, you have all these people that are working together, but there is another obstacle, right? And somebody else, again, was mentioning this before. If we are really fostering an interdisciplinary collaboration, you actually are working with different businesses that grew organically and independently, so they have different tools. They're using Python, R, SAS, whatever, and so when they have to collaborate or sharing code, they have real issues in doing so. So another thing that we're doing, we're actually creating and leading a set of best practices so that eventually the bank is able to harmoniously work together and be more effective. And last but not least, in order to anticipate and manage the risk, we work very closely with information security, legal, risk group, ethics. We are even thinking about new roles like the content authenticity function, for instance, given all the hallucinations that we have seen recently. So again, this is a very complex landscape. And if we really focus on the ability of data science to move the needle in the organization, you at least need to consider all these aspects. Now, I wanted to have a little fun here before I end my presentation. So I wanted to, since everybody, as somebody else mentioned, is talking about generative AI and ChatGPT, so I said, well, let me see if a metaphor that I thought of works for ChatGPT. So I did ask ChatGPT a specific question. So is advancing data science like a neural network? And let's see what it says. I put ... because I didn't copy everything, but yes, advancing data science can be metaphorically compared to a neural network. Here is how the metaphor can be understood. Layer structure. Well, surprise, it starts with foundational concepts and gradually builds upon them. Learning and adaptation. Advancing data science requires continuous learning, acquiring new skills, and to update knowledge. Interconnectedness. Advancing data science involves establishing connections and collaborations with experts, researchers, practitioners in the field. It relies on sharing knowledge. Feedback and optimization. Advancing data science involves an iterative process of experimentation. It emphasizes continuous improvement. Complex problem solving. We heard the previous kind of speeches. There are huge complexities in the problems that we're talking about. So in advancing data science is really tackling these complex challenges and extract meaningful insights from the data. Finally, advancing data science involves parallel processing, parallel computing, distributed system, and high-performance computing techniques. So I thought this was really cute because actually the metaphor touches upon a lot of the things that other speakers actually talked about. So this fun exercise, I guess, completes my presentation, and I'm open for questions. Thank you.